Okay, now we're moving on to the final portion of your exercise uh, 12.5. So I'm taking up just two questions for this class. You can do 22 yourself. We're doing 20 and 21 today. 22 is slightly different, not very frequently asked also in your exam. So 20 and 21, we will do it today, and then your mensuration chapter is over. And don't worry about the last exercise, 12 point. No, I don't think it's 12 point. Is it 12 point? I think it is 12 point, right? Yes, it's 12. So don't worry about the 12.6 portion, the frustum part. It consists of frustum part. Frustum is actually, it looks like this. You have a cone and then you cut it off here. So the shape will be, it will look like this. So make it upside down, you will get a bucket shape, right? So that is called a frustum of a cone. This portion is removed. So no need to worry about the last exercise, 12.6. I think if we do up to 12.5, it's going to be fine. And you have to be careful about this mensuration chapter here, because the most of the 6-mark question, it used, 5-mark question, it used to come from the 12.6 for mensuration chapter. The rest of the exercise, mostly 3-mark or 4-mark question or 2-mark question, 1-mark question used to come. So for your batch, for 2022, BOSM, what you have to do is you have to take every question seriously this time, because we don't understand which part we don't know which part we will expect the 5 marks questions from. Okay, so let's see question number 20. It says a spherical shell of lead whose external diameter is 16 centimeter is melted and recast into a cylinder of height 9 hole 1/3 centimeter and the diameter 16. Find the internal diameter of the shell. Okay, we have done similar questions in the past. It says spherical shell of lead. Spherical shell means the inside portion is hollow. Okay, so we have a sphere which is hollow. Look, the inside portion, it is, wait a minute, okay. This inside portion right here, this portion right here, this is hollow. It says a spherical shell of lead, right? The lead is here. This portion is the lead. You know lead, right? The metal that is in your batteries. So the lead is in here, this portion right here, and this inside portion, this portion right here is hollow. It is nothing but air in there. And what the question gives is the external diameter is given as 16 centimeter. Since this is a sphere, we have got the diameter. So we have got two types of sphere. This type of sphere, it encloses everything, the lead and the air. It consists of the lead and the air, this whole sphere. The inside sphere, this is nothing but air. Yeah. The external diameter is given as 16. And nothing else is given. The internal diameter is not given. We have to find this out. So this is melted and then we recast it. We recast it into what? Into a cylinder of height 9 1/3 centimeters. So we melt this and we made it into a cylinder. So anything given for the cylinder? The cylinder has a height 9 hole 1/3 centimeters. So from here to here is, this portion is 9 hole 1/3 centimeter. What else? And the diameter is given as 16. So diameter here from here to here, or let's say, let's draw it below. The diameter is how much? The diameter is 16 centimeter. So everything else is given for the cylinder. We need the radius and the height, right? Radius, we can find it out from the diameter itself. The height is 9 or 1 by 3. So we need radius and height of the cylinder, which is given. Coming to the hollow spherical shell or plate, we have the external diameter. Let's draw it here. External diameter is this part right here. So external diameter from here to here is given as 16 centimeters. What do we have to find out? We have to find out the internal diameter. Internal diameter is from here to here. This portion right here. We need this portion. Get it? So what you need to find out is from here to here. The internal diameter we need to find. Okay, how to solve then? Since this is melted to form this, since the shell is melted to form the cylinder, volume of the shell will be equal to volume of the cylinder, right? So volume of the shell, how will we find out the volume of the shell? There is no metal everywhere. Metal, the lid is here, the lead is here, this portion only. How to find out the volume then? From the whole sphere, if you cut off this portion, if you subtract this portion, then this portion will be remaining, right? So when you want to find out the volume of the lead, we have to find out the volume of this whole portion, and we will subtract the volume of this portion. And that volume of the lead is made into the cylinder. So volume of cylinder will be equal to volume of the lead. Get the idea? Okay, let's proceed then. Let's see. Let's start the solution. So it says a spherical shell of lead whose external diameter is 16 centimeters. So external diameter is given. We will convert it into radius. We don't have any use for diameter, right? So let's start here. Radius, external radius of the shell. How much is it? The diameter is given to be 16. We want only half, right? Right in the middle. So we will have 16 divided by 2, which will be 8 centimeter. And come to the internal diameter, internal radius. Let the external radius be denoted by some symbol. So, let the external radius be denoted by R1. So external diameter, external radius, we denote it by R1. Okay, R1 is 8. 8 will be from where to where? From here to here. Internal radius will be from here to here. Get it? External radius, you have to reach here. Internal radius, we don't know. We will take the internal radius as R2. What is the volume of the lead then? From this whole volume, you have to subtract this portion, right? Because this portion is air, there is nothing else there. So in order to do that, we will find out the volume of the whole minus volume of this portion. So it will be, volume of lead will be 4 by 3 pi R1. When we have R1, we take the volume of this whole portion. And what about this portion? This is still a sphere, so the volume will be how much? 4 by 3 pi R. Which one? 1 or 2? We will have R2 because we take the radius from here to here is R2. So subtract here. Okay, now we can take out common factor. 4 by 3 pi can be taken out as common factor. R1 is how much? R1 is 8. So we will put 8 here, 8 square cube. Minus 4 by 3 and pi has already been taken out. So R2 we don't know. We don't know the internal radius, so we will put here R2. Okay, now the shell and the cylinder. What was equal? The volume of the lid will be equal to volume of the cylinder, right? So you need to find out the volume of the cylinder separately. So let's mention here for the cylinder. The radius is how much? 16 divided by 2. Here the diameter is also not given. Radius is also not given. It is given in terms of diameter. So radius will be 16 divided by 2 centimeter, which will be 8 centimeter. What else? We are also given the height, right? The height is given as 9 whole 1 by 3. So mention here, height is how much? 9 whole 1 by 3 centimeter. If you multiply, 3 9 is 27, you add the 1. 3 9 is 27 plus 1, it will be 28, right? So 28 divided by 3. You have to be careful of the symbols that we are using here. The internal radius, we use symbol R2. External radius, we use symbol R1. We have another radius, and radius of the base of the cylinder, we use the symbol R. So no height here, so height will be here only, so we use the symbol H. Now find out the volume of the cylinder. Volume of the cylinder. How much is it? Pi R square H. Let's put in the value. We are not putting the value of pi. Okay, you will see in a moment why. And the R is how much? 8 into 8. H is how much? 28 by 3. Okay, in the next step, we are supposed to make the volume of the lid equal to volume of cylinder, because this is made from the lid present in here, this portion. So volume of cylinder will be equal to volume of lid, and then we will find out this R2 unknown. We will proceed it in the next step. Okay, you have to copy up to here. Copy up to here and tell me when it's done. Let's move on. I'm keeping this. Okay, so the volume of lid should be equal to volume of cylinder. So these two values, they should be equal. Okay, so in the next step, we will have volume of lid is equal to volume of cylinder. Okay. Yeah. So volume of lid is this portion right here, volume of lid. And volume of the cylinder is how much? Volume of the cylinder is right here. We can rub off the formula, pi r square H is no more needed. Okay, so in the next step, what we have is the volume of the lid is equal to volume of the cylinder. Now, what do we want to find out? We want to find out the internal diameter of the cell. Internal diameter, we denoted it by R2, right? The external, we denoted it by R1. So we can cancel out pi and pi. What else can we cancel out? 3 and 3 can be cancelled out also. Both of them are denominator. And 4 and 8, 4 2s are 8. Okay, whatever is left, you keep it. We have got 8 cube minus R2 cube is equal to 2 into 8 into 28. 8 cube is how much? 8 8 is 64. 64 and 8, how much? 8 4s are 32. 8 6 are 48, so 512. So 8 cube, we will put 512 minus R cube, sorry, R2 cube is equal to, multiply this. 2 8 is 16, 16 and 28. Okay, so we have got 448 here. Let's take away R2 cube to the other side, 448 to this side. So we are going to have 512 minus 448 is equal to R2 cube. If we subtract these two, how much is it? 512 and 448. So we have got 4 here. 7 minus 1, so we have got 6 here. So right hand side, we are going to put 64 R2 cube. Sorry, left hand side. 64 is 4 cube. Okay, 4 4s are 16, 16 4s are 64. So 64 is 4 cube is equal to R2 cube. You cancel the cube and cube. What is left then? R2 is equal to 4 centimeter. Okay, what is 4 centimeter? You have to understand. This part right here, the internal radius is 4 centimeter. But the question doesn't ask internal radius. It asks the internal diameter. Diameter will be from here to here. All right. We know only half. We know 4. This part must also be 4 since it's a radius. 4 plus 4 will be how much? 8. Or you can multiply 4 by 2. So how much is the internal radius then? Sorry, internal diameter. Internal diameter, you have to multiply R2 multiply by 2. So it will be 2 into 4, which will be 8 centimeter. So we know 8 centimeter is the diameter, internal diameter from here. Okay, this ends your answer. This is your required answer right now. Okay, copy. Don't take more than 2 minutes. Okay, this is very short. So this is your last question. Okay, this is slightly different. Okay, a vessel is in the form of an inverted cone. Okay, vessel is in the form of an inverted cone. The cone looks like this. Inverted cone, we will have this set, right? So a vessel is in the form of an inverted cone of height 8, radius 6. Okay, better draw the figure first. Height is 8 centimeter, radius is 6. So the radius is how much? This is 6 centimeter. Height is how much? 8 centimeter. Now it is filled with water up to the rim. So water is filled up to the top. Okay, everything is water. When lead salts, each of which is a sphere of radius 0.2 centimeter are dropped into the vessel, 1/6 of the water flows out. So here are some water. We drop small balls. Okay, small balls, lead salts. Okay, small balls which have a radius how much? 0.2 centimeter. We drop so much ball inside until how much water flows out? 1/6 of the water flows out. Okay, question wants to know, find the number of lead salts dropped into the vessel. If we drop lead salts, so many lead salts, then all the water can flow out. If we fill the whole cone up to the brim with lead salts, then most of the water is going to flow out. But how much water has flown out according to the question? 1/6 of the water has flown out. So question wants to know how much lead salt that we get, that we drop into the vessel. Okay. Okay, first of all, let's try to know how much water can this vessel hold. This vessel, how much water can it hold? Okay, that means we need to find out what? We need to find out volume. So for the cone, this is the solution. So for the cone, what is given? The radius is given as 6 centimeter. The height is given as 8 centimeter. What is the volume now? Volume or capacity? How much is it? What's the formula? 1/3 pi r square h. Let's put in the value 1/3 pi I'm not putting the value of pi, okay? Why? Because in the previous one, we can cancel out the pi and pi on both sides. That's why I'm not putting the value of pi. Let's just keep it there. The value of r is how much? 6 into 6. H is how much? H is 8. We can cancel 3 and 6. 3 to the 6. So what is left? The value is pi into 2 into 6 into 8. Still, I'm not multiplying it, okay? Now, this will be in terms of centimeter. This is the volume of water that will be inside here. You can convert it into liters. You can divide it by 1000 centimeter. But let's not complicate it, okay? Let's just keep it here. This much water this cone can hold. What does the question say? When we put lid shots inside, when we drop lid shots inside here, when we drop it inside, then the water level will increase. Finally, it will fall. But since it is already filled to the top with water, whenever we drop a lid shot, some water is going to flow out. How much water is flow out in total? In total, 1/6 of the water flows out. So you mentioned here amount of water which flows out. How much is it? 1/6 of the water. How much water was in the container initially? This much water was there initially before we drop the lid shots. So out of this, 1/6 is going to flow out. So 1/6 into pi into 2 into 6 into 8. Now we can cancel out 6 and 6. What is left? 2 8 are 16, right? So 16 pi centimeter cube. This much water is flown out. Okay. Why did the water flow up? The question is. Because when we drop the lid shots, the space that is supposed to be occupied by the water, it is being occupied by the lid shots. Right. So there was water initially here, everything was water. But when you drop a lid shot, when we drop one small ball, the space that is supposed to be occupied by the water is now occupied by the land. That's why the extra portion, the extra amount of water, it flows out. If we drop 2 lid shots, then more water will flow out. If we drop 3, more water, 4, more water, 5, more water, 6, more water. Question wants to know how much water, question wants to know how much lid shots that we put in there. We already know how much water has flown out already, right? So how much water flows out will be equal to the volume of the lead shots that you drop here. So volume of one lead shot we can find out because the radius of the lead shot is given here. So let's find out the volume of the lead shot. One lead shot, okay, for the spherical lead shot. How much is the radius? Radius is 0.2 centimeter. And what will be the volume then? 4/3. Right, properly. 4/3 pi r cube. So we will put 4/3 into, I'm not putting pi, the value of pi still. R cube will be 0.2 into 0.2 into 0. Okay, let's keep it this way. So 4/3 pi 0.2, you can change it into 2/10, right? 2/10 into 2/10 into 2/10. This 0.2 is here, this 0.2 is here, this 0.2 is here, this 0.2 is here. 2 2s are 4, 4 2s are 8. 8/10 multiplied 3 times, we will have 1000. 8/1000. So this whole portion I can change it into 8/. 1000. This will be in centimeter. Okay, you copy up to here. We will come. We will make the volume equality for in the next step. Copy up to here first. Tell me when you finish. Okay, I'm rubbing everything off, just keeping the amount of water that flows out. Okay, I'm keeping this portion just for reference. Okay. And the volume of the lead shot is how much? This portion right here. Okay, look. Actually, this much water flows out. What is this? This is the volume of one lead shot. Okay, spherical lead shot, one lead shot, the volume is this much. You can further multiply this. You can make it into 4 8s are 32. 3 and 1000, we can put it as 3000 pi centimeter cube. So when we drop one lead shot, this much water is going to flow. If you drop 2 lead shots, how much water is going to flow out? We will multiply by 2, right? If we drop 10 lead shots, then we will multiply this 32 by 3000 into pi. It will be multiplied by 10. Yeah, but we don't know how much lead shot that we have dropped. All right. So let's say we have dropped n number of lead shots. So you mentioned here, let n numbers of lead shots be dropped. So how much will be the volume of the n lead shots then? One lead shot, the volume is this one. We drop how many? N numbers. Okay. Why are we taking n? Because we don't know how much lead shot that we have dropped in there. So for n number of lead shots, what will be the volume? The volume of 1 is here. For 1, the volume is 32 by 1. Sorry. The volume of 1 is 32 by 3000 pi. What about 2 lead shots? We will multiply 2 into 32 by 3000 pi. What about 3? We will replace the 2 by 3. What if we have n? We will multiply n into 32 by 3000 pi. So for n numbers of lead shots, what is the volume? Volume will be n into 32 by 3000 pi. Okay, look. When we drop n numbers of lead shots, the space that is supposed to be occupied by the water is now occupied by lead shots. So the water that was there already, it will flow out, right? So the amount of water that flows out, this will be equal to volume of n lead shots. Okay, so you have to mention here, therefore, volume of n lead shots is equal to volume of water which flows out. Okay, I'm rubbing this off. Let's bring this up a little bit. Okay, now, how much is the volume of n lead shots? It's here, right? This value. So you put it down here, n into 32 by 3000 pi is equal to volume of water which flows out. Where is it? It is this value right here, isn't it? This value, so you put it down. So we will have 16 pi centimeter, sorry, no need for centimeter. What's our goal then? We want to know, find the number of late shots. Where is the number? The number is 10. We need to find out how much is 10. Okay, time for cancellation. You cancel out the equal one. Pi and pi got cancelled. 16 twos are 32. And then we can cancel 2 and 3000, which will be 1500. What is left then? Implies that n is left, 1500 is left, nothing is left on the right hand side, so we will put 1. If you cross multiply, n will be 1500. Which means if we draw 1500 late shots, then this much amount of water is going to fall. 16 pi centimeter cube amount of water is going to fall. So question asks, find the number of late shots dropped. So we will say, therefore, number of late shots dropped, it is how much? 1500. Okay, it's done. Copy up to here, and then your mensuration chapter is also done. Okay. So for your exam coming up in November, you're not going to set very tough questions, but you have to prepare accordingly. Prepare very well. Mensuration is a big chapter which carries so much marks. So out of the 80, I think it will carry more than 10 marks. So you have to practice every question carefully. All the exercise you still have. Counting today itself, there is more than 10 days, so that you can prepare. You divide each chapter for every day, and then you practice it repeatedly. I know that maths is a portion that where most of you are weak. So try to put in a little bit of extra effort. Okay. Everything is easy if you think it is easy. But if you don't put in any effort, then your thought is useless. Think everything is easy, and then you put a little bit of an effort and then practice it regularly. Everything will become easy. Nothing is difficult here.